Hello. So in this lesson we're going to have a look at integrating, where we first of all need to separate this expression here into partial fractions. So we've had a look at each of these skills separately in class. We've had a look at separating into partial fractions, particularly in this case where we've got a repeated root with the x plus 2 to the power of 2 there. So just here. Then we are going to have to follow that up by integrating the function, which is something again that we've looked at separately but we haven't put together. So starting off the question, the first thing you need to recognise is that it will need to be split into partial fractions before you can even consider the integration. So that's what we're going to begin with doing. Okay, so here we've got just that fraction, and what we want to do is recognise that that can be split as follows. So a value over the x minus 1 plus b over the x plus 2, just to the power of 1 at the moment here, plus c over x plus 2 to the power of 2. So this is how we would deal with that repeated root there to the power of 2. We would have to have two separate fractions, 1 to the power of 1 and 1 to the power of 2. Okay, so to go through and to solve this equation, we know that we would need to multiply the expressions on both sides through by x minus 1 and then x plus 2 to the power of 2. So on the left hand side, I'm now going to be left with x, 4x plus 5. I'm working with an equation now. So for my value of a, the denominator x minus 1 would cancel out with this bit here. So I'll be left with x plus 2 all squared. Then if I have a look at b, as we said before, this is just the power of 1. So I'm going to have these factors sort of remaining in my numerator there. X plus 2. Okay. And then sort of we're going to have c, I'll just squeeze that in there, and that's going to be left with just that x minus 1, as it will cancel out with that x plus 2 squared. Okay, I'm just going to do a little bit of tidying up here. Just to make it clear that that's what we multiplied through by and that it's not part of this fraction at all. Okay, moving on then, we need to solve for our values. That means that I need to make each of these brackets equal to 0 at some point by cleverly choosing a value of x. So if I have a look at this first bracket, I'm going to make x equal to minus 2. So on my left hand side here, I'll get minus 2 multiplied by minus 8 plus 5, so minus 3. The a is going to now be multiplied by 0, which is what I wanted to knock that bracket out, or that value of a. My b is now going to be multiplied by 0, because minus 2 plus 2 is 0. And then my value of c, that's going to be multiplied by minus 2 minus 1. So here I'm going to get the value of 6 is equal to minus 3c. So that will give me that c is equal to minus 2. Lovely. Let's have a look at the next one. So here I'm going to let x be equivalent to 1, because that will then allow this bracket here to be equivalent to 0. So on my left hand side I'll have 1 times by, so 4 plus 5, which is 9. And then on my right hand side I'm going to have a multiplied by 3 squared, plus the b times by 0, and then the c will also be multiplied by 0. So I'll get 9 is equal to 9a, so a is equal to 1. Wonderful. Okay, now this is why these questions are popular in the exam, because when we try to look at calculating our value for b, we realise that either value of x that we've chosen has currently sort of knocked out that value of b there, because the brackets following it equal 0. So we choose any value of x. It's usually worth going for something relatively easy. So in this case, we're going to choose 0. We now know our values of c and a, so we're going to use those to help us. So I'll move this up just a little bit. Okay, so let x be equal to 0 on our left-hand side. Okay, if you recall, we're going to have 0 times by 4x plus 5, but anything times by 0 will give us 0. On the right-hand side, we are going to have, so 2 squared times by a plus minus 1 times by 2b. So minus 1 times by 2b. And then finally, on the last one, we are going to have minus ac. So 0 is equal to 4a minus 2b minus c. We know that a is equal to 1. We don't know what b is. And we know that c is equal to minus 2. So be careful here, because we do already have a negative there. So we will have minus and minus 2, which will make that a positive 2. Okay, and so we have 0 is equal to 6 minus 2b. So 2b is equal to 6, and b will therefore be equivalent to 3. This, however, is not the question finished. Whilst we found the values of a, b and c, if you recall the original question, all this time ago, you'll remember that we are splitting it into partial fractions so that we can do this part here, which is to follow it up with the integration. So I'm just going to substitute my values of a, b and c back into where they belong in those partial fractions. Okay, so just carrying on from where we'd left off. So we've rewritten this into partial fractions. This is the original question here. So it follows that we are now going to have a look at integrating each of these separately. And you really cannot integrate the function that we were given originally as it stands. You must start to recognise that anything that has got an algebraic fraction of this sort is going to need to be split into partial fractions first. And obviously we always integrate with respect to dx. Okay, so the reason that this is such a popular exam question then is the fact that many students get tripped up on these things here. So these two functions have got a linear denominator, which is just to the power of 1. But this fraction has a linear denominator to the power of 2. So when we integrate these functions, and this is the skill that we did in our last lesson, you are going to get log functions. So it's always worth thinking about what function differentiates to give you a fraction. And you know, if we remember that from the last block, it's the log function. So that first function there is ln of x minus 1. There were no coefficients with the x, and so we don't need to worry about having any compensation at the start of our function, because we didn't really need to apply the chain rule in this case. Just a reminder though, had that been 1 over 2x minus 1, then we would have needed to realise that integrating this would have given us ln of 2x minus 1, and to compensate for the 2 there would have been a half when we differentiated. However, we don't need to worry about that in this case, but it is worth bearing in mind. So let's have a look at the next one. Again, I have got a linear function here to the power of 1. And I can see that I've got a 3 in my numerator, so I simply have a 3 here, and the log function of x plus 2. Finally, this function that I have here might be worth reconsidering it as the following. So I have got a 2 brackets x plus 2 to the power of minus 2. So if we wanted to think about that in terms of integrating, we increase the power by 1 and divide by the new power. I did obviously have, it was a minus 2 at the beginning there, so if I still have that minus 2 there, I need to consider how those two negatives are going to cancel out. So I don't want to be a heathen and forget my plus c. In total, or in all, we'll get ln x minus 1 plus 3 ln of x plus 2. Those two negatives are going to give me that positive, and then I have got 2 over x plus 2. Obviously the power of minus 1 there is the same as writing it as a denominator in a fraction, and that plus c. So there we've taken all of the skills that we've been working on in the last few lessons, and as I said, built them into one big question there. It's a mammoth of a question, really. Lots and lots of steps to consider along the way. But break it down into two parts. The first part, just work on the partial fractions. The second part, with the integrating, always have it at the back of your mind that you're going to have log functions and you're going to have this function here, which won't become a log. That always trips people up. Thank you for your time.